Alright, YouTube, let's keep looking at the chess computer. So what I want to do today is to implement something for bishops. So if we get a bishop, then we do the same thing. And we add them to the new positions. And at this point we can probably do something like this. And after the match we always do that. Let's check it. Yeah, the function doesn't exist yet. And it has the same signature as this guy, so let's copy that. And now the structure will be more or less the same. So we can copy paste a lot. But no, the first thing is that now we also need the ray attacks. And it keeps all the different types of rays, which one of the subsets of that is the what are they called? The bishop attacks. It also has the rook attacks, but we won't worry about that right now. So let's get the ray attacks. And now we want to do not this, but rather let's go into ray attacks to remind ourselves how it looks. Now we want to say for each ray and each type of ray. And it will look something like this. Let's say we start with the northwest rays. Well, we still need the occupancy of our own pieces. And then we have northwest attacks, let's say, will be the attacks at the right, so let's remove that. Then we do it here instead. So we find the index of the piece, and then we take that attack out of not 0, but northwest rays. Probably write a macro to do this a little bit more easily after, but let's start this. And there should be a let mutable, and then we want to remove all the ones where our own pieces are. And then didn't we have something in here called blocked ray attack, which should be public, because now we're gonna need it. Let's just grab everything. So now we have all those. No, let's not do that, because we also have the and we actually have implemented it here, right? So there's no point doing that again. So we also need the enemy occupancy. Actually, why don't we do it like this? Position that black occupancy and the reverse down here. Position that white occupancy. I think that's all right. Let's add a to do so the compiler doesn't complain, and then do check. So use of undeclared type in main. Right, yes. That is because it's called raise. Let's check it again. Raise, not array. And same up here. All right. Then we just need to import it. Okay, now we get some warnings over in move generation because we never use the raise. Okay, let's leave it for now. Okay, so going back to ray attacks, we already implemented the blocked attack, so we can say that northwest attacks is actually the blocked ray attack for the ray at this position. So that should be the correct ray. Then we need to provide the ray family. We need to tell if it's a forward ray, which in the case of the northwest it is. Then we supply own occupancy, enemy occupancy, and that is a bit board. So similar to what we did up here, we can extract the potential moves and then we do the same thing, I guess. And basically that is it. Now the thing is, we want to do this for all the rays we're interested in. So let's simplify it a bit, or let's abstract this away. Let's say let's get attacks, and it will take which one it is. So let's say rays, and I'm not sure what type it should have. It should also take whether it's a forward ray, so we'll call that an expert. Then we will do this basically. This format didn't like that. Did not like that because we need. There we go. So let's not call it attacks. Let's call it just ray attacks. Then we don't want this. We want raise. We want whether it's forward. Then we want to get the ray attacks here. And then we also want to put them all into the potential move list. And I think we can erase that. Which is referring to knight. We move this up here. And then we simply should be able to say get attacks for the northwest race, which is in forward, and there should be 3 more. Southwest, which is a backward ray, northeast, which is forwards, and this one southeast. Okay, let's just try to compile that. Interesting. Private field. Okay. Well, not anymore. Okay. Said it expected a, let's check this out. Blocked ray attack. Okay, it does expect a reference, so I guess we just add a reference. And raise doesn't have a new function, which makes me sad. There we go. And it has to be public. And there's some mutable thing that doesn't have to be there. This one. And move occurs here because type, what did we do in the other case up here? So let's have a look at the knight attacks, because I'm pretty sure we just said we were allowed to clone it. Let's do something similar. Implement clone for race. And then we will make a new race where northwest race is equal to northwest race dot clone, and so on. So I think that should do it. Let's go back here, try this. It's just not, what did we do up here? Did we really clone it? Ah, okay, I see the problem. Can we just get a reference then? That should be fine. Guess we didn't need the clone, but whatever, may come in handy later. Actually, I mean, we should probably never need to clone it. What? Will it work if I remove this? Yes, right, didn't care about that. Let's run the tests. Okay, that didn't work, so let's, because we changed something down here. Because we're calling initialize all the time. So let's replace initialize with new. Run the tests again. That worked. So we don't actually need this clone thing. So I just guess we remove it. Let's go back into knight attacks, remove that. Okay, so now we have this thing that's generating the blocked raise attack. I mean, for both of these types of moves, we're not checking whether our own king will be in check after that. Which we should remove those moves that leave the king in check. But I think we will do that a little bit later once we have more have a better idea of what the structure of the whole thing will be. So let's say we only have one bishop. Let's copy paste this almost empty position. And we will put a bishop in the top right corner. Like that. We'll get the game. I don't, maybe we should call it something other than not a lot. Let's just call it Fen. And then I want to say we get the new positions. For the first piece. And now what should the new positions be? They should be like all the way down the diagonal. So what are those indices? It's 0 and then it's +9 all the time. I think, yes. And now we do the same thing. We expect there to be this many. And we can do, we should make a utility function for this. Just gonna copy it for now. So for each position, let's get the piece, which is in this case the bishop, and okay, here we're just checking that we're getting the right piece. We don't want this one. There should only be one piece. And that should be it. Let's try to run the test for this file. It worked, but we have these print statements, which I'm going to remove. Let's check they're all gone. They are all gone. And it just worked. Let's make it a little bit harder. Honestly, this should be refactored, but I'm not in the mood today. So now it's kind of in the middle of the board. That means that we want something else. What do we want? So which position is it at, first of all? So it's I think it's at position 36, which means we should have again we have the like diagonal going from lower left to upper right. So 36 will give us these moves going up towards the right, and going the other way we get this. But that's only one direction, so we need to go in the other direction too, which is +6 all the time. I think. I don't know. Now it seems wrong. Right, we go. Okay, it's +7. Like that, and then it's -7 going the other way. So 36, 29, 22, 15, 8, 1. That's also doesn't look right. -8, we go 1 down, then we go 1 forward, so am I just not doing math correctly? Let's just try to run this, see what happens. Okay, we need to rename it. Yeah, great, so it fails. Let's, I don't know, print out these positions. Okay, the thing I didn't realize is, of course, that 15 is at the edge of the board, so there's no moves after that. So that was okay, but okay, so that's good. Now let's add some where we also have a friendly bishop. So if we go 1 up to the side, then everything, these should be removed. Didn't like that. Because this should be 2. And what else makes it fail? Who knows? Probably it's because it should be second piece instead. And also we don't do that. We don't need mute. Great. And so now we also have a case where a friendly piece is blocking. Now, to be fair, let's also try with black pieces. It works. And now let's try one where we have, that was not my intention. Let's try one where we have both friendly and enemy pieces. So let's say one friendly, one enemy. Now I could put the other one here and the friendly one, or the enemy one rather, also at that relative position. So let's see. Now what we don't want is this these ones over here, they will not happen. And when we go downwards, we will only get 1. So these won't happen. Let's try to run that. It failed because I copied a paste. Forgot one up here. Great. So I thought it would fail because it's kind of hard to keep track of a single piece. It's kind of quite hard to keep track of a single piece, like between positions, which to be fair doesn't necessarily make sense because you can have a pawn that promotes, but it does make these tests kind of hard. So perhaps we should do something like let piece. Now if the color is white and the position is contained in the new positions, then we do this. And it should either be 2 or 3. And I don't think this will work. Necessarily. Yes. Because we need to bit scan this guy. Bit scan. And we need to provide a reference. Now we can do it. Okay, yes, so this is the problem. It says possibly uninitialized. So how do we do that? Okay, so I refactored it a little bit and here's a way to do it. Let's, first of all, actually we should keep this one. And now I use a named for loop for the other one. I just call it outer. First I check on the positions is okay. I technically don't need this anymore. Let's remove that. Call this for piece. Let's call this piece as well. And now what I do is I loop through all the pieces. And once I find one that's in the expected list of positions rather, then I assume that's the one I'm looking for. And I don't need to do this because it's kind of implied by the if statement. But then when I find that, I continue. Now, if it ever happens that I never find a piece, so like the bishop has moved to the wrong location, then I will never succeed with this check, and then I go to assert false. So for example, this were the case, should fail, and it fails here. And can we see exactly where it failed? Panic at assertion false. Good. So go back, change that, and now everything runs. Let's just for good measure run all the tests again. 31 passed, 0 failed, 0 ignored, 0 measured, 0 filtered out, finished in 0 seconds. Amazing. So I think that's it for this time. Now we have the bishop moves, and there's a lot of code. Next time we will do the rook moves. Why not? Till next time.